Hello and welcome to my channel. This video is going to be about hemisphere specific views of the moon. And what that means is, depending where you live on the globe, and the globe that we live on is not up for debate in this video or my channel because physics says it's a globe. And all the other examples in our solar system says it's a globe. So again, that's just not up for debate or even part of this video. But this concept does prove both that the moon should not cartwheel and that the earth is round. Okay, so hemisphere specific views means people in North America or United States see the moon differently than someone in Australia. We see the northern hemisphere sees it one way and the southern hemisphere sees it exact opposite. So left side lit, right side dark would be right side lit, left side dark, and then on opposite hemispheres. Now, the moon should never change its appearance hourly. Minus 7.2 degrees of libration that happens throughout the month, along with the phases. So we're talking about, when we talk about the moon rolling, we're talking about an hourly change of our view of the moon. Now, the only way you could see the moon roll, like what we're seeing now before 2010, was to travel the globe from north to south or south to north. Traveling east and west never changed how the moon looked from your point of view. Alright, so I'm going to show you someone who is traveling boat or plane from the North Pole to the South Pole, and watch what happens. Here we have my moon analog. It's right side lit, left side dark. Now as I travel from north to south, what begins to happen? My view of everything becomes turned to the side because I'm now at the equator. Let's continue south. Wow, look how that terminator line just starts turning. Now we're in Antarctica. I'm going to flip it back up, show you equator, North Pole. Okay. Just traveled around the globe. Okay, that is hemisphere specific views. That means someone here would see the moon slightly tilted all the time. The turn line would be slightly tilted. It wouldn't do this every night. Not back and forth, just northern hemisphere we're seeing clockwise, so clockwise spin every hour. But I just showed you that can't happen unless I go north or south, travel north or south. So someone here in North America, in United States, sees the moon one way, slightly, mostly vertical, slightly tilted. The North Pole, they see the terminator line completely straight up and down. This is pre-2010. This is how it's always worked until now. Equatorial regions, they see the moon sideways. And the moon goes by as we spin on our axis. The moon only moves 6.2 degrees in 12 hours, 12 point whatever, in 24 hours in its orbit. The Earth and moon go by because of this, the spin. Alright, so southern hemisphere sees exact opposite of the northern hemisphere. Proven fact. No debating that. If you want to argue that, then have at it, my friend. But that's a proven fact. Everyone can see that. And everyone has seen that for thousands of years. The sailors used the moon because it was so constant as a navigation tool. They could see how the moon turned as they traveled the globe north to south. And that still happens, except now we just have to deal with the current rotation that we're seeing due to the Earth being tilted over. Now, I'm not talking about circumpolar spin, we're talking equatorial objects. Suns, planets, moons, constellations are all turning cartwheels. Clockwise in the northern hemisphere, counterclockwise in the southern hemisphere, mostly outside of equatorial regions like your temperate zones. Equatorial regions, the moon is doing something a little different. It does a combination of things depending where you are and where it is overhead. You'll see clockwise the 4-hour flip of 180 degrees and counterclockwise, possibly even all in the same week, without moving, without traveling the globe north or south. Sitting in your porch or your favorite scenic outlook or overlook, shouldn't be able to see the moon do this. And I know before 2010 the moon didn't roll, it always stayed the same. It rose and set in the exact same orientation because it is an equatorial object, meaning it's on the ecliptic plane to us. Or maybe not, I shouldn't say equatorial, it's on the ecliptic plane the same as we are and the sun and the other planets. So it's along our horizons. Therefore, the objects on our horizon should never rotate like a clock. Field rotation does not cover it. Field rotation is for telescopes and keeping the object in the field of view so that it can be photographed or recorded, long-term exposures. And we're not doing that. This is naked eye observing, so that eliminates field rotation. Hemisphere specific views pretty much eliminates any other excuse out there or model someone wants to make up. It's pretty clear. And really, no troll can argue with hemisphere specific views, and they don't. They will always avoid it. For 2 years, or actually over 2 years, I've always brought up hemisphere specific views, and no troll will ever debate it because they can't. It's impossible to debate hemisphere specific views of the moon. It tells us exactly how the moon should look based on your location every night. And we're not seeing that now. So, here's my little toy I made a video about. It's a simple little thing, and it's still chugging away with this little solar panel. And there's a stick hanging down. It has a magnet glued to it. It's running down the center. And it's wagging back and forth because the solar cell is putting energy into the coil. There's a copper coil, wire coil underneath that magnet. So the electric field that the solar cell is creating as the energy moves through the coil is creating its own electromagnetic field, therefore moving the magnets above it. When you put them opposite polarities, then they're going to want to repel each other, and this is how that toy works. And when the energy goes away, the coil no longer has a field and the toy stops. Very simple concept, but so true in our daily lives and our universe. So, alright, enjoyed making this video, and we'll see you on the next one. Laters.